Hello learners, and welcome to the first part of our lecture about acid-base equilibrium. So of course, new part means new pre-lecture, right? And this means that you're going to be completing the one-pager brain map. You're going to be looking at previous information like reviewing a concept and completing a practice problem. And of course, this lecture and the others will enhance or add to the pre-lecture information. Why is this going to be important? Specifically, that reviewing previous information part. Well, this information today is going to include acid-base equilibrium problems. Those equilibrium problems are similar to what we saw in chapter 13. So going back to review, equilibrium problems, etc., are going to help you understand this portion effectively. All right, folks? Also, we just completed exam number 2. So you know how important it is to create new habits and skills to get the outcomes that you desire. And giving yourself enough time to do the work and using free resources available to you will help you along the way. So if you need support with understanding concepts, you have office hours and tutoring. If you need support with your mental health, you have counseling, right? If you need support with time management, you need support with being able to deal with test anxiety, you have the ability to use the study skill workshop and get further accommodation. So these are all things that you want to use to support you to get the outcome that you desire, right, folks? All right, so let's get to thinking, and let's get into chapter 14. Okay, in this chapter, we're going to be applying the equilibrium concepts we learned in chapter 13 to acid-base phenomena. So if we go back to 101 and we're like, what is an acid? What is a base, right? This is what we learned. We said acids are sour, bases are bitter. We were even given specific examples. We said, okay, we have citric acid, right? That's going to be a flavoring for lemon juice. We have baking powder, like the aluminum salts that are in baking powder, for example, can be seen as an acid. We also have our bases, which our main one would be like ammonia. We know that's a household cleaner, right? We also have sodium bicarbonate, right, which could be used for a type of fire extinguisher. So we have all these little details we may have learned. One other big thing I remember we learned in 101 was a neutralization reaction. So we learned about reactions, and we learned that if we have an acid like HCl mixed with NaOH, which is a base, they're going to be in a reaction, do double displacement to form a salt, which is NaCl, and water. And if you were to write the net ionic equation, it'll simply be H plus OH minus to form liquid water. And so this is kind of the extent that we learned, right, from 101. But guess what? There is way more that can go on with acid and bases once they're mixed together. And what we learned here is not the only way to help us understand those particular phenomena. So what do we have to do? We have to go dig deeper. We have to add layers of information, right? And that means that even though these initial definitions had their unique features, they helped us kind of distinguish between acid and base very simplistically, right? We need advances in science, advances in better definitions, right, to help us understand a wide range of acid-base phenomena. And that's what we're going to be doing today. So what definitions or models are we going to learn about? Well, there's 3 of them that we're going to focus on for the entirety of chapter 14. The first is going to be the simplest, which is the Arrhenius of acid-base definition, okay? Then the one that we're going to talk about the most is the Bronsted-Lowry acid-base definition. And the goal is that as we're adding in these definitions and adding in information about them, we're not eliminating the previous one, right? We're layering. So there's going to be some acid and bases that are easier for us to use the Arrhenius equation to describe. There's going to be some that is easier for us to use the Bronsted-Lowry equations or definition to describe, not equation, sorry. And then also there's going to be certain acid and bases that is easier for us to describe them using the Lewis acid and base definition. Now the cool thing is we've seen Lewis acid and base before. If we go back to chapter 19, right, and we talked about complex ions and that they form that coordinate covalent bond and form those adducts, right? Guess what? Those are Lewis acid and bases. So we get to get more details of that today as well. More specifically in the rest of the parts of chapter 14, okay? So let's talk. All these different models and definitions are going to help us understand a lot of detail when it comes to acid and bases and how they behave in different equilibrium systems, right? We also get to add in more details like the pH scale. So we talk about pH scale, we'll talk about the pOH scale to help us do that. We'll also go even further and use these models and definitions to help us classify acids and bases. So now we'll be able to see strong acids, strong bases. What is a weak acid, a weak base? Then it's even more cool because we can say, depending on whatever type of acid and base you have, strong or weak, depending on their ions. So if I was to take HCl and break them down into ions, I'll have H plus and Cl minus. That means if I have the Cl minus or H plus and I mix it in any kind of salt solution, I will be able to tell whether and predict really whether something is acidic or basic. So that's pretty cool, right? And we're going into those details as well as we get into chapter 14. Let's go ahead and get into this chapter. So now the question becomes, yeah. We know we're talking about acid-base equilibrium. How are you talking about the Avengers? Where does this come from? Well, first, let me start explaining my analogies. First, the Marvel Avengers are a team of superheroes that can include like Iron Man, Captain America, Thor, or the Hulk. Okay? And of course, many others. And they all come together to protect the world from powerful threats and maintain peace and justice in this entire Marvel universe that is created, right? But in our world of chemistry, or in our chemical universe, much like the legendary Avengers who assemble to restore balance and harmony, our chemical Avengers are going to play a crucial role in maintaining equilibrium, okay? And so what I've done, when I start thinking about strong acids, weak acids, I automatically start thinking about different powers that these different Avengers have, and this is how I built my analogy. Does that mean I'm going to use every single Avenger? No. Does that mean I'm going to throw in some villains? Yeah, because villains sometimes play cooler. So yes, I will be throwing in some villains and things like that. Really, we're thinking characters from the Marvel universe, but the Avengers, that name is just really cool, right? So that's kind of how it came up in my mind. I'm like, well, if I have different types of acids and bases and they mix together, I can use the Avengers to help with that analogy. And remember, folks, this is simply just an analogy, nothing else to it. It's all to aid in active recall of the material. So you can change the characters how you want, okay? You can add in any supervillains like I was talking about to add a little razzle dazzle, or you can completely say, I don't care about this entire analogy and just focus on the information I'm telling you. It's all up to you. But instead of seeing Iron Man, for example, we'll have the weak base ammonia Iron Man. Instead of Captain America, we're going to have the conjugate weak base, which is going to be HS minus Captain America. Instead of Thor, we're going to have the strong acid HNO3, which is going to be HNO3 Thor, right? And then, of course, with HCl, instead of just saying Hulk, we're going to have HCl Hulk. So it's just basically us adding on whatever Avenger that we can use. And because it's a strong acid, for example, I think of Hulk, he's very, very strong, right? Hulk smash. When you're thinking of Thor, he's very strong as well. He also has his hammer. And then when I'm thinking of Captain America, he is a weak base, for example, but that doesn't mean he's weak. So we'll talk about details about what it means to be a weak base, a weak acid, and why we say weak versus strong, right? We'll get into those details as well. And since we're talking about equilibrium, it's also pretty cool because we get to learn more about different types of equilibrium variables that we can use to help us describe this information too. So we're just used to capital K, right, for equilibrium constant, or Kc or Kp for concentration or pressure. Now, we're going to see Kw for water. We're going to see Ka for acids. We're going to see Kb for bases. And so we're just layering and adding in more info. That means we're going to go through different characters. They're going to have different strengths and weaknesses. And of course, that's going to apply to whatever type of acid or base that we classify them as. All right, folks? So let's organize ourselves about what this particular part is going to be about. Well, first, we're going to get the Arrhenius definition of acid and bases, which is the most crude, right? And then we're going to go into more detail about what a Bronsted-Lowry acid and base definition is, okay? Once we have our Bronsted-Lowry acid-base definition, that's going to help us get through the majority of our entire lecture here. We'll talk a little bit about auto-ionization of water, okay? The ability for water to produce itself, and the pH scale. We'll then go into details about strong acid and bases and pH calculations. So yes, there is a lot to memorize here. For example, you will have to be able to recognize what a strong acid and base is. As we go further, you will have to be able to recognize what a weak acid and base is. And so it's going to be important for you to have those flashcard moments and to take your time and also really organize the information. I try to organize my bets in the presentation I'm giving you, but then you want to take it further and organize it for your own brain. All right, folks, let's go ahead and get started into that Arrhenius definition.